Hi there, we're on to video 5 now of the exponential and log functions video series, this time having a look at exponential equations. With exponential equations, we're going to do a fancy thing to solve these three examples, and that is to take, we take the log of both sides. So we're actually introducing a logarithm part to each side of this equation, and that'll allow us to do a fancy thing using logarithm law 3. So if we take the logarithm, just put the word log on either side of this particular equation as it stands now, we'll have log 3 to the power of x equals log 16. And as you know, the logarithm laws suggest that any indice, log law 3, says that that x up the top can come down and multiply down the front here. So if we kick in that law there, we have x times log 3 equals log 16. And there's a multiply between there. So if we divide both sides by log 3, we'll have x on its own, which is what we need to solve equations usually. So we get log 16 over log 3. Now we can stick that straight into our calculator, saying log, into our calculator here now, log 16 divided by log 3, just pressing our log button. We'll press equals and we'll get a decimal here. Let's write the full version of the decimal. And if the question might ask us to round off however we see fit. But that's the x value that we get from that. Now it's interesting, we take the log of both sides, and then we're kicking in log law 3 to move that x down the front. And then we're just solving the equations from there by dividing both sides to get x on its own and using the log button on our calculator. Okay, it's going to be getting familiar to us, this like taking the log of both sides. It's a great way of solving exponential equations. If we didn't do this, we might be just there trial and error trying to find the right value of x, and that might take us a while. In a similar way, this is going to be very familiar to you now after watching that last example. Let's take the log of both sides. If we take the log of 4, and the power is x minus 5, equals the log of 9. And we're going to take that whole x minus 5 indice and bring it down the front, pretty much the same as what we did last time. This time I'm going to put a bracket around it just to separate it. That will be multiplying by log 4 when it gets down the front there, and we get log 9 there. Now there's a multiply there. Our next step will be to divide log by log 4. Don't need that equal sign. Okay, so when we divide by log 4, we get x minus 5 equals log 9 divided by log 4. And to get x on its own, which is what we're trying to do when we solve things, we can add 5 both sides. So we get log 9 over log 4 plus 5 this time. And our final x answer is somewhere around 6.58. I might have rounded that off, but 6.58 for that solution to 2 decimal places anyway. Okay, so once again, we took the log of both sides. We have to be a little careful with our indice coming down to put it into brackets, otherwise it might not work very well. But pretty similar method to the first one. Okay, our third and final example here is pretty similar, except we're going to use log to the base e for our log of both sides. I'll tell you about the button on the calculator in a minute, but because we've got an e here, we're going to choose log to take the log e of both sides. So bear with me with this one. We have log to the base e to the 3t at the moment, equals log to the base e 5. Now what we can do here is to use that log law 3 again to take that 3t down the front. So we have 3t times log e, and we'll talk about that in a moment, equals log e 5. Okay, now when we do that, I wonder if you remember one of our logarithm properties from last video said that log, where you've got the base e and the number is e there, or the value is e there, that asks what power have I got to put the base to get the number, and that power equals, that answer of that question equals 1. So this bit here in the box, that equals 1. So we're kind of left with 3t equals just the log to the base e5. And to get t on its own, we will be, as you could probably predict, dividing by 3. Log to the base e5 over 3. And plugging that into your calculator, what you'll have to do is use a button that looks like this with an ln. That's actually log to the base e. So log to the base e5 divided by 3 equals, that should go on your calculator, and you should get a value of t that equals 0.54 when we round it to 2 decimal places. It's a longer one, but I'll cut to the chase there and round it for you. When we round anything, technically we should put approximately equal to, because it's not equal to that anymore because we rounded it off. Okay, two differences here. We took the log e of both sides, which we're allowed to do. Last two examples we took log 10 of both sides, and that created a special result here where we had log to the base e, and that equals 1. So we're able to process that as one of our properties there. Okay, not a whole lot trickier than what we were doing before. All three examples ask us to take the log of both sides and then just solve our equations from there and use our calculator wisely. So all the best with exponential equations.